Here's the coordinate plane, and I like to set this up using a tabular format where I list the vectors A, B, C across the top, and then I go across adding all the vectors that are acting in the X and Y direction. Now these are the vector components that I showed you on the previous slide. So let's get the values now, and you see the X component of vector A is 80 cosine 65. You can see the vector flashing as well as the value. The X component of vector B is 100 cosine 20. And the X component of vector C is vector C, and that is a negative value, so that is subtracted. Now, if you're not comfortable with your trigonometry where you can come up with these values as I have right across the top, don't get stressed out. I'll show you on the next page where you can calculate these values off to the side and then plug them into this table, and it will look just like this row here, where I've done the calculations. The sum of the X components is equal to 33.8 plus 94 minus 60. That gives us a value of 67.8. And we'll do the same thing for the Y components now. The Y component of vector A is 80 sine 65. The Y component of vector B is in a negative direction, so that has to be subtracted. So it's the negative of 100 sine 20. Vector C does not have a Y component at all, so that is 0. We put these values into the calculator, and we come up with 72.5 plus negative 34.2 plus 0 is 38.3. Now you can see what this looks like down here. So the sum of the X components, 67.8, can be represented by the vector here. And the value for the sum of the Y components can be represented by this vector, purple one here. And these should look familiar, as we already had these drawn on the previous slide. Now I'm going to pick this up, the Y, some of the Y's, and you can see our Y component. That's our two legs of a right triangle. So we can then define the resultant by using a Pythagorean theorem. And we'll take the square root of our sum of the x's squared plus the sum of the y squared. And we get a value of 77.9 for the resultant. And let me click on it, and you can see that value, what the vector looks like, and what the value is.